Yeah, okay. So the next thing we are going to solve now is question 3. It has one VHDL question and one state space question, specifically up-down counter using flip-flop. So we are going to start with 3 here. 3, it says design a mode 4 up-down counter using T flip-flop. Mode 4 up-down counter using T flip-flop, and sketch the logic circuit. Okay, so now first off, let me try and explain what an up-down counter means. So up-down counter is a counter that can count 1, 2, 3, 4. If you notice, this is counting upward, and it can also count 4, 3, 2, 1. So this is counting downward. So this is the up and this is the down. That's where this gets the name up-down counter. Okay, now, so another thing we need to take note is the mode that we have. So we have mode 4. So basically mode 4, the numbers in mode 4 are 0, 1, 2, and 3. That's just basically them. Now, if they write it like this, up, down, so when you have 1, or let me just see, let me draw the two tables for you to see first, so you get what I'm trying to say. So the table of this one is going to look like 0, 1, 2, 3. Let me just put here, we have up, down, and we're going to have A, B. So since the maximum number of values that we can have is 3, so this is going to be 0, 0, 0, 1, 1, 1. I mean 1, 0, 1, 1. So we only need A and B. This is going to be A, this is going to be B. So we have A and B, and these are the present states, and this is going to be the next state now. Also A and B, and the flip-flop that we need, which is T. So we are going to need TA and TB. So for the up-down counter, we are going to have 0, 0. Normally, since we have 3 variables, this is going to be 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 1, 1, 0, 0, 1, 1. And this is going to be 0, 1, 0, 1, 0, 1, 0, 1. So 0, 1, 2, 3, 4, 5, 6, 7. So anytime you have 0, 0, zeros, that's like a bar, and that will be correspond to down. And anytime you have 1, 1, 1, that's going to correspond to when you are counting up. So 0, 0, 0, you are counting down. 1, 1, 1, you are counting up. So now let's see. If you're at, since we have 0 here, it basically means we are counting down, Abby. And if you are counting down, this is going to be 0. What's going to be the next state if you are counting down? So what we have is 0, 1, 2, 3. We have 0, 1, 2, 3, and this is counting up. 3, 2, 1, 0. Counting down. When you're counting, no, so since we are on 0 side now, what we are doing now, we are basically counting, we are counting down, right? So when you are on 0, the next state is going to be 3, Abby. So the next state of this one is going to be 3, and that's going to be 1, 1. So when you are on 1 and you are counting down because of this 0, the next state is going to be 0. So 1, 0. So that's going to be 0 0. Now the next one is 2 0 1 0. When you're on 2 and you are counting down as a result of this 0, the next state is going to be 1. So that's going to be 0 1. And the next one is 3. When you're on 3 and you're counting down, the next state is going to be 2, right? So we have 2. That's 0. What's 2? 2 should be 1 0 1 0. And now we have flipped to the upside. That is, we are going to be counting up as a result of this one. So when you're counting up and this is 0 0, so this is you're not going to treat this as 4 since we are actually dealing with mode 4. So you are going to start over again. This is 0, and 0 when you're counting up, the next state is 1. So the next state we have here is going to be 0 1. Then when you're on 1, the next state is 2 1 0. When you're on 2, the next state is 3 1 1. When you're on 3, the next state is 0. Now the next thing for you to do is the flip-flop. So to do the flip-flop, we have to make use of the excitation table. So the excitation table is for T flip-flop is qn plus 1 and T, which is 0 1 1 0 0 0 1 1 0 1 0 1. So 0 1 1 0. And we have this. Now we have to look at it here. For TA, we have to consider these 2 columns. So this is 0 1. TA will be 1 0 0. TA will be 0 1 0. TA will be 1 1 1. TA will be 0 0 0. TA will be 0 0 1. TA will be 1 1 1 0 1 0 1. For TB 0 1 1 1 0 1 0 1 1 1 0 1 0 1 1 1 0 1 0 1 1 1 0 1. Wow, that's interesting. So the truth table that we have is this. So the next thing for us to do is to draw the K map for TAT and TB. So now let's draw the K map. Since we have 8, we are going to have how should I draw this K map? Let me draw it like this. So this is the up down, and this is AB. This is 0 0 0 1 1 1 1 0, and this is 0 1. So 0 1 2 3 4 5 6 7. So when do we have 1? We have 1 at 0. We have 1 at 2. We have 1 at 5. And we have 1 at 7. That's all. We only have 4 ones. So we are going to circle this one and this one. So the simplified expression for this one is going to be, that's going to be the up down and 1 1. That's B. B is the one that is not changing. Plus for this side, the up down is bar and B bar, right? That's going to be B bar. So that's for TA. So we are going to do the same thing for TB. Well, we notice TB is always 1 everywhere. So this is going to be up, down, A, B. So everywhere is 1. So we have to circle everything. 0 0 0 1 1 1 1 0 0 1. And when you circle everything like this, TB is simply equals to 1. So now we have our TA and TB. So the next thing for us to do now is to draw our circuit diagram or logic circuit, whatever you want to call it. So we are going to have two flip-flops like this. That's TA, TB, and they are going to have an output of QA bar, QB, QB bar. Whatever that is coming out of here is going to be A, and this is going to be A bar, this is going to be B, this is going to be B bar. Also, we need a clock for this one. Yeah, okay, so now to the input side, since we have up down here in our counter, that's going to serve as an input. So we're going to have a line for that, a line of up, down, and the line is going to have another line for hand of this. And also we are going to need a clock. So clock, we have that line for that. So now let me join all the clocks together first. So we are going to have the clock for this one, we have the clock for this one. Now the next thing for us is, if you notice, let's start with TB. If you notice, TB is always 1. So in order to do that, we just basically going to say TB, we are going to have a high line, and the high line is going to join to TB. So now for the expression of TA, we notice that TA is up down B plus up down bar B. So up down B is going to be this one. So from TA now we are going to have an OR gate. An OR gate that has two AND gates. That has two AND gates. So the first AND gate has up, down, and B. So we have a line from up, down, straight to B, to this place, and B, let's see, where can we take B? Yeah, we can take B like this. So that's going to be up, down, B. And the second one is up, down, bar, B. And this is up, down, bar. And this is B bar. So this is what our circuit will look like. That's the end of this.